Welcome to a new episode of the ITU Journal webinar series, where you can find insights and forward-looking research on future and evolving technologies. The ITU Journal is an international journal providing complete coverage of all communications and networking paradigms, free of charge for both readers and authors. This publication considers yet to be published papers addressing fundamental and applied research, building bridges between disciplines, connecting theory with application, and stimulating international dialogue. Its interdisciplinary approach reflects ITU's comprehensive field of interest and explores the convergence of ICT with other disciplines. We count on your support to make this webinar an interesting experience. Please submit your questions via the Q&A channel at the bottom of your screen. All questions from the audience will be taken during the Q&A session after the talk. The meeting is being recorded and the recording will be made available on the webinar website. Closed captioning is also available for this event. You can enable this by clicking on the closed caption icon at the bottom of your screen. We hope that you will enjoy the talk and we encourage you to stay connected until the end for the Wisdom Corner. I will now give the floor to our Master of Ceremonies.
Hello, and welcome to the webinar series with academics of the ITU Journal on Future and Evolving Technologies. My name is Alessia Magliarditi from ITU, the International Telecommunication Union, the United Nations Specialized Agency for Information and Communication Technologies. It is my pleasure to open the webinar today with Professor Silvia Giordano from the University of Applied Sciences and Arts of Southern Switzerland. We count on your support to make this webinar an interesting experience, so please submit your questions via the Q&A channel. We will address them to our speaker during the Q&A session. After the Q&A, please stay online. I will moderate the Wisdom Corner, live lessons. Professor Giordano agreed to a personal chat. She will share with us some lessons learned over the years that might perhaps be useful for some of you. I'm pleased now to introduce Professor Iana Kilditz, Editor-in-Chief of the ITU Journal and founder of and president of TRUVA from the United States. Professor Kilditz is Ken Byers Chair Professor in Telecommunications Emeritus at the Georgia Institute of Technology. He established many research centers worldwide, including in South Africa, in Spain, in Saudi Arabia, and Finland. He is Editor-in-Chief Emeritus of Impact Factor journals, highly cited and at the top of the most prestigious international rankings. Ian is visiting distinguished professor in several universities around the world. His current research interests are in 6G, 7G wireless communication systems, hologram communication, terahertz communication, molecular communication, Internet of Bio-Nanothings, intelligent surfaces, nano networks, and many other subjects. So I'm very pleased now to give the floor to Professor Kilditz for his opening remarks, to introduce the speaker and moderate the Q&A session.
Thank you, Alessia. Thank you very much again. Greetings from Abu Dhabi today. I again welcome you all to our ITU Journal for Each Future and Evolving Technologies webinar series. Before I present today's speaker, Professor Silvia Giordano, I would like to briefly talk about our journal. The objective of our journal is to bring the academia and industry together. The idea for our journal was initiated back in December 2019. I remember like yesterday when we met with Alessia and the then director of the office at ITU, Chasup. And actually that was their idea. And then we started to talk about the details. And then we launched the journal. And it took for 1 year to publish the first issue in December 2020. And we have many issues in the meantime. Also with Alessia and again, our former director, Reinhard Scholl, we had this idea about webinar series and we started to implement, realize that too. And now we are in the 4th season. So it's going really very well and very successful. So we are continuing today with yet another excellent speaker. So about our journal, it's an open access journal. There are no fees for readers and no fees for authors. The papers go through a rigorous review process, and we try to cover all forefront, and timely research activities in the academic and industrial world. The journal is a product of a big team effort, and I would like to acknowledge them here. Our new director, Sijo Ono-san, yet another new director, Bilal Jamusi. Of course, I mentioned Alessia many times today, Alessia Malarditi. Actually, she is the main driver of all these events, I have to admit. And yet another driver, Erika Campilongo, and many others for their work. Actually, I have to also mention our new addition, Maria is with us from Barcelona. And so I really greatly appreciate their work, efforts, and continued support and dedication for the success of our journal and our webinar series. I encourage you all to submit your papers, and also if you have ideas for special issues on popular topics, please do not hesitate to contact us. Today, I have the great pleasure to present you our speaker, Silvia Giordano. First of all, on behalf of our entire journal team, I personally thank Silvia to accept our invitation, or to have accepted our invitation, and is giving this webinar today. My first interaction with Silvia, I hope she will remember it, was more than 25 years ago. I'm not trying to reveal her age. She was only 5 years old that time. So when she was a guest editing a special issue on satellite networks for an IEEE journal. She was very kind, and Contact Man invited me for a paper contribution, which I had accepted, and published a paper entitled Satellite ATM Networks. In the last 2.5 decades, we have met many times at different conferences. Now, I'm afraid that she will say that was not her, right? I'm sure it was her. Silvia Giordano is a professor at SUPSI, which stands for University of Applied Sciences and Arts of Southern Switzerland. She has many, many hats. Like one of them is Research Director of the Information Systems and Networking, ISIN, Head of the Trustworthy and Secure Information Networks in Society, Head of the SUPSI Research Area on Digital Ecosystems, in short form ASE5, Associate Researcher of CNR Italy, and Distinguished Professor at University of Tianjin in China. She is co-editor of the book Mobile Ad Hoc Networking, The Cutting Edge Directions, which was published by IEEE Wiley, co-edited or whatever, co-published in 2013, and of the very successful past edition Mobile Ad Hoc Networking, again by IEEE and Wiley back in 2004. So my statement was right, in 1999. So you can imagine, right? So she had all the success in 2004. So which have been considered one of the reference books for ad hoc networking. Silvia's main research interests are complex and social networking, wireless and mobile ad hoc networks, opportunistic computing and networking, and human mobility, pervasive computing and networking, quality of service, and traffic control. So last time I met Silvia last June, and she told me that she was working with her team on these emotional sensing. I was very, very excited, and then we decided to collaborate, and we started to collaborate with her group, and I was really enjoying it. And in October, somehow, our love ended, because there was no funding. So I hope we can revitalize that collaboration, because the topic is extremely interesting. Emotional sensing is a really fantastic research area. Silvia received several career awards, and in 2021, she has been nominated chair of the ACM Distinguished Scientists Committee and the chair of the IFIP, we call it IFIP, Working Group 6.3. Without further ado, let us listen to our exciting talk and to our Sylvia. Thanks a lot again, Sylvia.
Thank you. Yeah. I don't know how can I start the talk now after your introduction, but thank you very much, and welcome everybody to this webinar. So let me share my screen. Can someone confirm that you can see my screen?
Yes.
Okay, perfect. Then the webinar of today is on clearly next generation internet, and in particular on three characteristics of next generation internet, that are transparency, privacy, and performance. And my talk today will follow the outline here, very simple. We will try to understand what does it mean novel traffic frontiers, and then I will introduce you the concept of dark triad that is in the title of this webinar, and motivate why I use this in the context of networks. And then I will show you a real study case on 6G data networks. So let me start with the point of traffic and next generation internets. As you know, we talk a lot about 6G, and the vision of this 6G networks is to have an automation of services by means of AI, artificial intelligence. Basically, this was somehow called by industry 4.0, 5.0 applications, but also other fields have pushed the networks to do this step. And this means that the network has to be an intelligent environment with cognitive and collaborative characteristics that are brought by AI in a conversational way, so in a way that allows to communicate and understand what they are doing. And one of the major idea behind that is also to remove the human being from such process, to have real automation and remove the probability of human errors. And AI is the core of the 6G for enhancing from 5G to 6G networks. And the idea is that with AI, we can create some sort of dynamic automation that is dynamically evolving with the evolution of the traffic condition, the routes, and the devices. So if AI on one side can improve the radio system or mobile radio systems by optimizing the channel and adapting the channel, and people has estimated something like a 30% save compared to existing state. On the other side, also the algorithms can work at the device level, turning off and on base station and other devices in periods that they don't need to be on, and then there is reconfiguration on in real time. In addition, AI will be clearly paramount for management and optimization of networks that are becoming more and more complex, for example, with the introduction of Internet of Things into the network area. And AI is able to solve challenges of network optimization much faster than traditional systems, because, as you know, can analyze a huge amount of data in a very short time, so produce best routing solution, even in cases where we have multiple route traffic sources, but also can be fundamental in detecting anomalies and faults, and to do that in, let's say, real time or in quasi-real time, avoiding a loss in performance quality. So, as you can see, AI is becoming central of the future of networking. But let's now introduce the concept of dark triad, which is a concept that is very far from technology, because actually is a concept of psychology, where dark triad is considered the three personality traits of narcissism, psychopathy, and Machiavellism. The three of them are very diverse, very distinct, but they have similar characteristics like manipulation, selfishness, ruthlessness, and basically the concept is to work for their own gain, disregarding or with little regard for others. So even if they are very distinct, the effects in some way are the same, and somehow they do collaborate to create very nasty people. And for people working in social networks, social media, they are very well known. So why the dark triad of next generation internet? Why we want to have dark triad, or we talk about dark triad in networking? Because we have three elements that are fundamental of modern networks, like transparency, privacy, and performance, that in some way, similarly to the psychological dark triad, are working to create some nasty effect. So thinking to the fact that we say that next generation internet will require AI, we have to see how these three elements of transparency, privacy, and performance can be integrated in this 6G vision and can build new and advanced networks. But on the other side, how can we avoid this network AI dark triad? Let's start with transparency. Let's try to know our three elements. Transparency is an understanding of how AI algorithms are making decisions. And this means two different components that are often confused, but they are distinct. The first one is explainability. That means to understand the reasoning, the logic and the reasoning behind some decision. So why the AI algorithm has taken this decision, while interpretability is the concept of being able to predict an output when you know the input. So in some way to give some, it's not correct to say deterministic, but to really possibility to know in advance what will happen with some type of input. And the two of them are clearly crucial for transparency and for AI transparency, but there are several other elements that are very important, like open data handling or understanding of models limitations, and also elements like biases and the context of usage of the AI algorithm. Then let's move to privacy. Privacy, it's probably more known as a concept, and we talk about network privacy when we talk about protective some sensitive information during processes like storage, processing, and transmission, and protect them from unauthorized accesses, but also usage, sharing, and display. So network privacy, it's clearly a subset of data privacy, and it involves several methods, several schemes and technologies to protect such data, sensitive and private data, but also the communication of them and the preferences related to them. And on one side, that's really related on networks, but it's also important for the users, in particular with the evolution that business applications are taking nowadays, because the data that are transmitted are data that are very, very sensitive about the users. And it's not only the sensitiveness is not only about their content, but it's also about other more implicit elements like location, for example, or frequencies that can disclose several information habits about users. So the network privacy is a subset of data privacy, but cannot clearly detach from data privacy. And finally, performance. I think everybody knows what is network performances, the analysis that is done for network performances, and also the fact that they are both qualitative and quantitative. And definitely at the very end, it's probably the most important driver for network administrator for choosing one network or another. So why they are a dark triad in that sense? Because there is an important trade-off among the three of them. Because when we talk about AI transparency, or commonly say explainable AI, that can open the door to misuse, like, for example, identifying resources or network status. At the same time, the detection and resolution of faults and anomalies may have a contrast that is required for performances, may contrast with privacy protection. And also, still in terms of performances, we can say that the better a human can understand an algorithm, so the more it is transparent, the less accurate and performing is. So as you can see, the three of them are working, are swimming in a different direction. And clearly we need to take care of that in that. And to show you the importance of the three of them in reality, I will present you a study case that is a very evident study case for 6G. That is the case of a multi-domain network function virtualization system. We are taking this as an example because, as you know, network function virtualization plays a crucial role in supporting 6G services when they require high reliability, and because this enables the implementation of network functions, as virtual entities. And in that way, they can dynamically allocate and manage according to the needs of different 6G services, entities, etc. And so they give this network function virtualization is giving flexibility to network operator for this type of new services. And the question we pose to ourselves is, can we have an efficient and transparent and privacy-preserving management of this multi-domain scenario in case of failure detection? So let's move on and try to analyze the scenario, first of all. So we know that this type of virtualization is using sort of classes of network functions that are virtualized into building blocks that may connect or chain together to create the complete, to deliver the complete service. And so it's built upon the traditional server virtualization techniques that is used in enterprise IT. And multi-domain network function visualization system consider an architecture, a network where that spans across multiple administrative domains that are managed by independent single domain orchestrators. So what happens is that you have several domains with a different administration. So in some way, they can even be competitor that are managed by a single multi-domain orchestrator. That's clearly owning and operating both the physical and the virtual network that puts together this system. On the other side, we have the single domain orchestrators that are the orchestrator of each of these domains, and therefore they operate the virtual network functions within their own domain, with the access to the resources, the communication, and the relationship with the other domains. So here you have an architecture where you can see this type of concept, and you can see three domains with three orchestrators. So each of them has its own single domain orchestrator. They are clearly distinct, and you have a multi-domain orchestrator on top of it that coordinate the orchestration of the virtual network functions. And you can see the virtual network functions are depicted in this service chain below, where you have the first function that is associated in the first domain, the second in the second domain, and the third in the third domain. But each of these domains can only see its own virtual network function and is not aware of the network functions that are in the other domains. So let's try to do a stop here to try to understand how transparency, privacy, and performance are fitting in this scenario. So in terms of transparency, we have as I show here, we have 3 single domains, and we have someone on top of it that is orchestrating, so taking decision. Then what happens is that each single domain clearly wants to know why the multi-domain orchestrator operates in that way, why the physical and the virtual network are moving, are acting that way he is doing. And on the other side, also the multi-domain orchestrator needs to know the data in terms of resources, network status, etc., of each single domain in order to apply the network function virtualization. On the privacy side, we have that each independent domain do not want to expose sensitive data to the other orchestrators, or even worse, to potential attacks from outside. And finally, in terms of performance, clearly the MDO, but also the SDO, do not want to have some malfunctionings or service disruption, and also do not want to add too much overhead to the system to manage the complete network and all the possible malfunctioning. So it's clear that these 3 requirements are orthogonal, because transparency requires that the MDO is sharing information about its decision that are based on global knowledge of the single domains, and clearly in that way exposes such information to potential attacks. Privacy requires that the opposite. So the MDO is not sharing or shares with privacy preserving techniques such information. And performance, as we said before, requires that the control that is done by the MDO is minimizing the additional action, the overhead on the system. So now let's focus on a specific problem in this scenario. And the problem we focus on is failure management. So failure management is when of these one virtual network function fails. Like in this picture, we can see that the virtual network function 2 is failing, and we can see the failure in the virtual and in the physical world. And this means that the complete service chain is failing. So now the point is that we are, in that sense, we need to have a system to prevent this problem to stay forever. So we need to do the failure management that is composed by 2 elements. The first one is failure identification system, that is this identifying and mitigating the failures in a timely manner. And clearly you already understand that this is also using a lot of information that are related to the single SDO that can be clearly sensitive. And also the fact that these observations are sensitive can make them also business critical, because, for example, we could have one of the 3 domain have an SDO that is malicious and dishonest. So, for example, the domain 1, knowing the failure of domain 2, could try to benefit of the fact that several services cannot work anymore on domain 2 and take the role of domain 2 with several applications. So in that sense, the SDOs are not willing to share such information about their own network and their own failures. But on the other side, these observations are fundamental for the MDO to understand what happened and to take the most effective solution. And on the other side, for the SDO to understand why the action taken by the MDO are such. So some examples, simple example of information to be protected are clearly the network packets received and sent, the network status, and network resource utilization, because they give clear figure of what is the domain that is that has been sharing this type of information. So how can we build this failure management system? Clearly AI-based, so very efficient and able to manage a large amount of data, very performing, privacy preserving, and transparent. And this will see that means to build several components and to take care of each of the three elements of this dark triad. So the components that we need to build are in first place, a multi-domain data sharing, because the multi-domain orchestrator needs to do to manage the failure in a very efficient way. But at the same time, we need to have some privacy protection for the data of the single domain operators. And finally, as we said, we want to be compliant with the new rules of AI usage. We need to have explainability of the AI model. So in that way, the SDO can understand the MDO decision also. And again, I want to remark the fact that the three requirements are orthogonal, because if we use Xi and the decisions are transparent, some global knowledge is shared. If we do a performing management of these multi-orchestration schemes, we need to share some global knowledge in order to have a very good orchestration. And clearly, in terms of privacy, we have issues because the SDO doesn't want to share information on resources and status, and in this way, the MDO cannot know well how to do this management, and on the other side, the SDO cannot know why the MDO has taken some decision. So the first element of our architecture is vertical split learning. I'm sure that many of you are familiar with the vertical split learning, and this is very useful in terms of performance and privacy. So split learning is a type of federated learning approach that it allows a set of distrustful parties to jointly train a neural network-based systems in a sort of privacy preserving manner. So the split learning, through the split learning, several parties, like in our multi-domain system, can jointly do this training of data, doing the train locally instead of having this in a centralized way. And then in this way, they increase the privacy protection. The split learning approach can be either vertical, that is the one that we will use in this in the following of this presentation, or horizontal, and this depends on how the data set is split among the involved parties. And the vertical split learning is very, very suitable for collaboration of entity like we have in this multi-domain virtual network function scenario, because they hold different subset of features related to the same observation. And at the architectural level, I mean, vertical split learning is a neural network that is distributed among a set of L clients and a server. So you can see the clients on top of these architecture and the server below. And you can see that each of them is training a different set of features with different neurons. And each client has then its local neural network. And once this training is finished, is done, then there is at the cut layer, there is a concatenation, there is a merging, better, of their output that becomes the input for the server that completes the neural network up to the exit, the output for this neural network. And basically on the server side, we have this merging, and then we have these components that are able, I mean, this merging is including the gradients of all the local training performed by each domain, and then the server completes this in its final layer. And we will see that we can use several types of merging techniques, and I will discuss better on that afterwards. The output, the gradients of the server model can be used by the clients to calculate the gradients for each batch, and then use that to update their own models. And another important observation is the fact that the more large is the split, so the more components we have, the lower is the accuracy of the system, because in that sense we are fragmenting the feature, and this lead to negative effects on model performance, because basically we are splitting the exported split neural network and the first layer of the network clearly will not work properly. And here is the complete framework, because till now we have talked about one component, that is failure identification. But in order to do network function virtualization, we also need to do failure location. And in this architecture, I show you two possible solutions for failure localization. One is still using the vertical split learning architecture, and the other one is to use an explainable deep learning approach, actually with two possible components that are deep lift and integrated gradients, with this second component that is able to give also explainability. So let's start with failure identification, which is the common component of the two models. And let's consider a VSL with L clients and one server. And we have that clients have a local model with a given number of layers. In this case, we think about 3 layers with 32, 48, and 64 neurons. And then the server model has also 3 layers, where the first one is equal to the neurons, the number of neurons after merging contributions. The second one has 64, and the last one is clearly equal to the number of classes that we are wanting to classify. And as I said, there are several merging techniques. I will show you that we did some measures to understand what is better, and it came out that concatenation technique is the best. So, as I said, there is a second component. First of all, let's model the second component with VSL. In this case, we do localization, failure localization with the very same neural network as we have done for the identification. And in this approach, the clients, again, collaborates to build this automated system. And there is no transparency, so they don't get information on the why this happened, and that's why here there is no transparency. I mean, as I said, we also want to provide transparency. So starting with the same failure identification, we also want to have some way to give to the SDO the possibility to understand what happens, and also to the server, to the MDO, the possibility to localize the failures without the collaboration of SDO. I remember to you that in this case, we had to do the training, the multiple training, or the vertical split training, as we have done for the identification. So it's possible to do it without that. And can we provide also transparency? And the solution in that sense is made by this explainable deep learning solution, where we use the information at the cut layer, so the concatenate server input, and we give that to, in our case, we use 2 different schemes. One is deep lift, and the other one is in integrated gradients, to try to understand which are the most important neurons that influence the output, and in this way localize the failure. So basically, this is a technique called feature attribution that by highlighting the most relevant neurons, so how features influence the model decision, are able to discover where is located the failure. So let's assume, for example, to have a number k of most influential neurons. If the top k minus y are part of this very same domain, a given client, then this means that it's very likely that the failure is belonging to this client if k and the difference between k and y is very high. So if k minus y is very close to k, then the failure can be attributed to this client. And so this is the complete solution where we do failure identification with VSL and the localization with this XDL. So let's take our architecture with these two possible solutions for localization and bring this into a real case where we use the ITU AI/ML in 5G challenge dataset that is generated within an NFV-based test environment. And we will do, first of all, an analysis of the best merging techniques. We will also show some baselines, and then we will perform failure identification, comparing the VSL-based scheme with some centralized approaches, MLP and GCN, use as baseline. And then we will do the same for failure localization, where we compare the VSL, the XDL with the two possible options, with a centralized approach that we also build with the XGBoost. And clearly, evaluation metrics for people very familiar with AI are the traditional accuracy, precision, recall, and F1 score. So that's the scenario of this data set, where there are 5 virtual network functions and 5 nodes, that 2 IP core nodes, 2 internet gateways, and a router reflector. And they are on 4 clients. As you can see, you have the IP core nodes on the same client, while the other 3 are on 3 different clients. And on top of that, we add this multi-domain orchestrator, as we discussed till now. So we also have 5 clients. And as I said, each virtual network function is with one of these nodes. So, and as you can see here, you have on one side this topology, and on the other side an example of a single data record, where you can easily see that the vertical split learning does not give the same room, the same number of features to all the nodes. In our case, client 1, that is the one with the 2 IP nodes, has 42 features. Then client 2 and client 3 have 24. Client 4 has only 9, and client 5, that is the multi-domain orchestrator, has 22. So, and that's an example of this division. This data set comprises two extensive collections of failure records that are divided in two data sets. Data set 1 that has about 6,000 records with more than 2,000 failure records, and data set 2 with above 5,000 records and with close again to 2,000 failure records. So you can see that there is an a high presence of failures in these data sets. And here you have the type of features and the failure classes and their distribution in the data set. So you can see here different type of features here, and then here the description of the failures and how they are divided in the two data sets. Also, we have divided the failures into the 4 clients and into the 5 nodes, with around 400 failures in each of the IP nodes, and then we have again about 400 failures into the interior gateways, and the remaining 170 into the RR01. That's example of dataset 1, and similarly we made for dataset 2. So benchmark approaches, clearly we need some benchmarking in order to validate, measure and validate our solutions. As I said, we have for failure identification, we use 2 state-of-the-art schemes that are centralized, that are MLP and GCN, while for failure localization, we developed, again, a centralized benchmark based on extreme gradient boosting. And first of all, as I said before, we wanted to understand what is the best merging technique to apply after the cut layer. And we made this measurement using all the possible solutions, so concatenation, sum, average, max, and products. And concatenation was the best on all the 4 metrics we use, so we selected concatenation. Also, sum, average, and mean and max, are quite good, while products was really performing badly. And now let's start with the comparison of failure identification. So let's start comparing our scheme, the vertical split learning, with the centralized scheme. So we have this scheme, and in this scheme we have sorry, I skipped one slide and I didn't want to do it. We have the performances here in this table, and you can see that the accuracy of the proposed vertical split learning is not that far from the centralized schemes, but also in terms of precision, it's quite good. Apart from, precision is quite good, while there is some problem in recall for BGP injection. But apart from that, I will say that the performances of the decentralized model based on vertical split learning is much, much better, and clearly it includes the fact that it is offering a stronger security in terms of privacy preserving. And we measured the very same scheme also with the data set 2. I didn't put the table here, but performances are very, very similar. So in terms of location comparison, localization comparison, we did the very same story. So we made an analysis of the two schemes where we use either failure identification with the very same system with VSL, or we do localization with XDL. And here you have the results where you can see that the VL-based scheme, it's very, very close to the XGBoost centralized approach. And if you take also the IG model of the XDL schemes, so the second failure localization, you can see also in this case that performances are not as good as the VSL based, but also not too far from the centralized scheme. In addition, this is offering protection, transparency, so understanding of why the MDO is taking some given solution, because this information is known by all the SDOs. Without, and there is an additional, I forgot, there is an additional advantage in this case, because you don't need to do the training of the neural network like we have seen for failure identification, and as you have to do in the case of VSL-based localization. So let me skip here. If we compare the two proposed models, I mean, we have seen that both are getting very close to the centralized scheme.
Sylvia, excuse me, Sylvia.
Yeah.
Our 1 hour is over, so can you please
conclude? So,
yeah,
sure.
please.
I have 2 slides and I concluded.
Okay, good.
So
thank you.
You can see that the on one side we have better accuracy, but we increase complexity and also training and overhead. On the other side, we have explainability and no need of training, but performances are slightly worse. I want to spend one single sentence on privacy, because as you have seen with the XDL scheme, we use the concatenation at the cut layer. And this means that in any case, the VSL scheme has some privacy holes that needs to be addressed in the future. And to conclude, I have double conclusions. One is on the real case, where we demonstrate that it's possible to do at the same time to obtain good performances, privacy protection, and transparency. But clearly, there is a trade-off between the three, and we have seen that we found a hole in privacy, and performances are slightly diminished. So the very conclusion is the fact that this network AI dark triad exists, And the three components in the future works on 6G must be carefully considered. Especially privacy sometimes is somehow neglected because someone is saying, oh, yes, let's put this privacy preserving scheme. But then once you add transparency, you also create a hole in the system that is again generating privacy issues. So further work is required in that sense. There are several groups working on this. Apart from my group, also I know that in Harvard they are working on that, and I'm sure they are working in several other groups on that. Let me spend 1 second on the team that has been working on that. First of all, Fatima, who is a PhD student in my group, a very smart PhD student, I have to admit. She was performing most of the analysis that I have been showing in this presentation, but also the collaboration of Omran and Davides was paramount to bring the work at this level. And here you have some contacts for the paper that I'm sorry I forgot to mention when I passed on it. That is the paper of Fatima, where we present the part on the real case work that was in my presentation. You have my address and you have my location if you want to visit me. And this concludes my presentation. Thank you, Jan, to let me go to the end.
Thank you, Sophia. So thank you. And very nice. We are informed about these virtual or vertical learning and how they can be used for the slicing. So I was personally happy to see that you use the ITU AI and machine learning in 5G challenge data set. So I'm sure.
I mean, I swear, Jan, that we did that before you invited me for the seminar.
I know, I can imagine. Yeah, of course. So we had done that. So I'm sure Alessia will inform the ITU colleagues and they'll be very pleased to hear that.
Yes.
So I'm trying to see that are there some questions from the audience? There was one comment about synthesia by Kyle, but I don't know. I asked him what he means by that. So he didn't get back to me. If he wants to clarify the question, please get back to us. In the meantime, I can ask you, and I was working on these slicing issues back in 2015, of course, without machine learning techniques. So one of the challenges that time was the internetworking between legacy and these SDN and FE-based systems. So what will happen when you have your solution in case of these vertical learning and supporting that slicing? Will that help to that internetworking case?
I think so, because in some way this type of slicing of split learning is somehow transparent. So you don't have to do any type of interaction between the different slices. There is this operator on top of that is clearly virtual, but is not a centralized entity. So you don't need to send all the data to this one. And basically what you do is what you will have done if you were the only domain in the story. So if I can get back to the picture where I do have, let's say here to show you again the ITU model. So basically, basically you have, let me see, I think I have one bigger picture of this. is not that bigger, but basically what you have here, you have two IP core nodes, this TR01 and 02, that are clearly connected each other, but they don't have to exchange any type of information about each other, as well as these internet gateways or the router reflectors. They are interconnected because clearly the service has to be passed. I mean, the virtual chain of service has to pass from one node to the other, but they don't need to know what are the roles of the others, they don't need any type of knowledge. The only one that has a sort of complete picture and is not a correct description is this multi-domain orchestrator. So, and the additional advantage of this solution is the fact that so when you do the training, let's say at TR01, you have this small part of the network, let's say this one, with your own number of layers, own number of neurons that are totally independent from the other nodes or domains. And the only place where they get merged is after the client cuts layer, that is into the server. So the server is the only one who gets the information from everybody, but actually doesn't get sensitive information because it gets only the gradient. So the output of these layers that are trained at the local level. So I will say in that sense is really a win-win solution. As I said in my final slides, there are still issues on privacy because it's true in some way is preserving privacy because you show only the gradients, but I have shown you that some explainable scheme can exploit this merge layer where you have the merge of all the gradients of all the different local domains, and at that level it's possible to discover some information that are sensitive, like the localization of the failure, without knowing anything about the multi-domain orchestrator or the single domain orchestrator. So that's the point where there is need of further work. We are working on that. I'm sure several other people are working on that. And hopefully there will be a solution, maybe a trade-off. I don't expect to have the perfect solution where you have full explainability, full privacy, and full performances, but a good compromise of the three.
Okay, thanks, Sylvia. And unfortunately, there are no questions from the audience. So I ask Alessia to take over and ask you questions or discussions in the Wisdom Corner. Thanks a lot again, my dear Sylvia. So I'll be back then.
Touch and keep in touch.
Yes, of course. Yeah.
Hello. Thank you, Sylvia. Thank you very much for your presentation. Thank you, Ian, for moderating the Q&A session. So now we can move to the Wisdom Corner, live life lessons, which is based upon the idea to give a unique and special angle to this series of webinars, adding a personal touch. So if you agree, I would start with my first question.
Sure.
So I would like to ask you, which is your hard-earned life lesson or failure that you would like to share with us today that might perhaps help somebody attending the webinar or even watching the recordings later?
Okay, but it's question on general, my career, my research life, or specific to this webinar?
No, in general, definitely in general. All your career, all your professional path.
Okay, I
Even
can
in your university.
think that happened to me and happened to some of my PhD students, because I think, I mean, I'm very, how can I say, I love to give messages that can be useful to young researchers that are the ones that needs more push in to stay into research. So what happened to me, as Jan was mentioning, in the beginning of my PhD, I was working with ATM. And I don't want to enter into ATM, but for really millennials people and Generation Z people, ATM was considered the new technology, network technology that was going to replace TCP/IP technology, and it failed. I don't want to enter in details with that, but the fact that happened to me is that I spent more than 1 year of my PhD on this topic. And actually, at given day, my supervisor came to me and said, you know, there is no future in this direction. We can continue if you want in this direction, but your thesis will be meaningless. At that point, you know, I slept badly for several days, but then together with him, we decided to move on TCP/IP and still on quality of services. And my thesis was then quite interesting. So I think this is a very important lesson, because then I had cases of PhD students who spent in one case even 2 years on some topic, and after that period we realized that it was not the best direction for several reasons, and then we moved on something else. And I can tell you 2 of them got a laude for their PhD, and all of them have a very good job. One of them is professor now. One is a senior researcher in an American company located in Zurich. So, I mean, it's important to think that research is not something given. You can easily fail, but failure doesn't mean abandon. Keep on going, believing in that, because I think you can find a direction, and also the experience, the failure can be a good experience, because you learn what not to do.
Sure. Yeah, makes sense. Thank you so much for sharing this experience. I would like to ask you what, actually, in which field and in which topics you would recommend students to study today. Is there any current trends or emerging areas of research that you find particularly exciting or promising?
There are many. I think Jan was mentioning this, let's say, virtual reality plus holograms, whatever. And this is really a hot area, because technology is not yet very advanced. So industries are spending a lot of money, but they couldn't be ahead research at the moment, because technology does not allow to do it. So it's still possible to do very, very interesting research in this field. I will not say AI, because I think AI is slowly becoming a sort of commodity. So clearly, I mean, there will be always people researching AI, having new schemes, more advanced ones, and the CPU, GPU technologies will allow to have better, I mean, to run more complex systems, etc., etc. But at the very end, I don't think that the future is in AI, because everybody is already now or will be able in the future to use AI. I mean, we can think about the LLM raise in the last period. So AI is important. I suggest everybody to knows it, but not. I mean, in my view, is not AI that will be the field where people can do research.
All right.
Yeah.
Yeah,
Then,
sorry, you wanted to add, yeah.
Yeah, I just wanted to add that there are several other fields that are very, very interesting and probably a little bit more obscure than the ones I mentioned, like, for example, fields that puts together the human side with the technological side. Jan was mentioning before emotion. Work a lot on emotion recognition related to technology, and this is really at a very infant level, because it's very, very difficult. I can tell you, even to create a data set is a nightmare, and you need multiple competencies, like psychological competencies, technical competencies, statistical competencies. So it's
Many
really
disciplines, of course.
exactly. That's really a fascinating word. And privacy security as well, because the more new technologies are coming out, the more hackers and malicious attackers are entering in the field. So, yeah, I think this is probably what I think can be useful.
Thank you. And what advice would you give to young people interested in pursuing a career in academia or research? Can you identify some key skills or qualities that you believe are essential for success in research?
Yes, I mean, what I like in a PhD student, so the beginner of this career, is when they are very curious. So you need a lot of curiosity. You need the capability of finding the problems, because research is not solving the problem. Research is finding a problem. And everybody is able to solve a problem. To me, this is a matter that can be done by a master's student or even a bachelor student when she has the capabilities. But in terms of finding a problem, that's completely different. And as I said, you need curiosity, you need, I mean, you have to be prepared to spend time in finding nothing, but then getting excited because you found a bit. And, I think, I mean, my personal experience with research is definitely positive. Not only because I love to do research, because I love what I have done, but because also I met fantastic people, and I exchanged really a lot of interesting thinking, work, and I think the more our society is getting complex, the more problems will appear. So it will be very, very important to have good researchers in the new generation.
Very clear. What initially sparked your interest in your field of study, and how did you pursue it?
Oh, that's a very good question. You know that I had a non-traditional career, because I did research for some years, and then I moved to a supercomputing center, but to be the network manager, so no more research-oriented job. And then I decided that I was not satisfied, and I moved back to the academia. I think was curiosity. I mean, for me, it became, after a while, it became really boring to have to do every day the same type of job with minor challenges, with things that someone else had discovered, and just to apply things in a sort of passive way. I wanted to be, let's say, the owner of what I was doing, and then I said, okay, let's try to do again research in that sense.
Cool. I have a last question. Could you tell us one of the most tangible contributions that you have made in your career that had an impact on your life, professional, personal, or on others' life that you're most proud of?
Okay, in terms of research, for sure, is the mobile ad hoc networking results, where we were able to shape the field, to build on top of that the opportunistic networking, opportunistic computing. So this was a field that was growing thanks to, in a small part also thanks to me, and I'm very proud of that. But that's for research. The things I think I'm more proud of is the people that have been able to grow. Because, you know, I started to cry when one of my students say to the committee for professorship, if I'm here, I have to thank Sylvia. And this was really, you know, touching. And I think, that's probably what I believe is the role of people like Jan as first, but also like me, and everybody who is working in research is not to do, you know, the new Nash equilibrium or discover the new relativity or whatever, but rather to be able to pass the message, pass the passion, help new generations to do research, because you are alone, and new generation is several people, so you can grow a big group and have more forces that do research.
Absolutely. Thank you so much, Sylvia. Really, I hope you enjoyed this webinar. Same way I did. Thank you very much. And Ian, for your last word, we say goodbye and we thank Sylvia.
I am back. You see, I have so we have a
ready
banquet
for
here.
Another event.
Yeah, we have a banquet here tonight. So, yeah, in Abu Dhabi. I'm in Abu Dhabi, so I will take a taxi and go to this hotel for the banquet.
So enjoy your event, Ian.
Thank
and
you.
Thank you so much, Sylvia. So
thank you, Sylvia. Yeah. And
Thank you,
Alessia, for moderating the Wisdom Corner.
Thank you.
And of course, thanks to Erica and Maria and us, into our team. So, Sylvia, I hope we'll be in touch. And
sure.
hope we can revive our collaboration. And I was so excited to continue the work, and then we had to.
I know. Even Davide will love it, but he is really operated by research that he has to do, and you know, many is the driving.
And also the other guy, Iranian guy, were upset that we didn't continue, right?
Yeah.
Anyhow, so I hope we'll revive it someday. So thank you again, and I hope to see you somewhere in the summer or in the future.
Maybe at networking. Who knows?
Yeah. So we'll see. Yeah. Okay.
Thank you again. Thank you so
Alessia,
much.
are you announced? Yeah. Thank you.
The next webinar will be on the 7th of May. with a professor from Politecnico of Torino, Fabiana Chiasterini.
Carla
Wow.
Fabiana Chiaserini, and actually she was here. She gave a keynote this morning.
All right.
Carla,
The wonderful person I met thanks to research.
All right. You
yeah,
see?
Carla
Okay.
Carla is here. She gave a keynote here about machine learning, so we'll enjoy her last week. So yeah, we have a bunch of speakers lined up the next 6 weeks.
Yeah.
Yeah, I know.
We
Thank
have
you
many
again,
in
ladies.
June as well. Yeah.
Bye.
Okay,
Thank you.
bye.
Thank
And
you very
enjoy
much.
the evening.
Bye.
Ciao,
Bye.
ciao,
Bye.
ciao.
Ciao.
Adios.
Bye.
Bye.